Here in problem 8, we're going to look at the collection of points such that the imaginary part of z minus I is the real part of z plus 4 minus 3i. Let's just make an observation before we get started. If we write, as usual, z is x plus iy, then the imaginary part of the left-hand side is going to involve a y. And on the right-hand side, the real part of the argument here is going to involve an x. So we're going to have something involving a y, something involving x. Likely what we're going to get from this is some sort of line. Okay, and so let's compute away. So in order to understand this better, we're just going to compute the left and right-hand side. So the imaginary part of z minus I is the imaginary part of x plus iy minus I is the imaginary part of x plus I times y minus 1. And you have to, again, write your complex number as a plus ib in order to figure out what the real and imaginary part are. If we just stopped in the middle here, we wouldn't be able to tell. So what's the imaginary part of x plus I times y minus 1? Well, it's y minus 1. All right, so that's our left-hand side. Let's work on the right-hand side now. Again, we're going to plug in z is x plus iy. In order to take the real part, we need to write this as a plus bi. So we'll collect the x and the 4 because they don't have an I, and we'll factor an I out of the remaining terms. Okay, now that it's written of this form, we can see that the real part is x plus 4, and that's our right-hand side. And we want to know, the question is, when are the left-hand side and the right-hand side the same? So we're going to set them equal to each other. So the left-hand side is y minus 1, and the right-hand side is x plus 4. Or we can write this as y is x plus 5, which is a line with slope 1 and y-intercept 5. So we'll quickly graph that. 1, 2, 3, 4, 5, 6. 3, 1, 2, 3. Mark some points. 5, down 1 over 1, up 1 over 1. There's our imaginary part of z minus I equals real part of z plus 4 minus 3i. That's the solution set there.